Hey Algebra 2, in this video I'm going to be teaching you about the properties of logarithms. There are proofs that go along with these, and I'll make a second video if you're interested in seeing the proofs. So for positive numbers, B, I'm going to do some color coding, M and N, with B not equaling 1, the following properties hold. Alright, so just like exponents, logarithms have properties. We're going to talk about three: the product property, the quotient property, and the power property. So the first property is the power property of logs. Sorry, product property. I wanted to do product first. Product property. So the product property states that if you have log base b of m times n, so we have a product of two numbers m, n, that can be rewritten or expanded as log base b of m, plus log base b of n. Notice, right, so it was log base b. When we break it up, these both have to have the same base. So you can, if you're given something like this, you could expand it, and if you're giving something expanded, you could rewrite it as a single log. So that's the product property. Now let's do the quotient property. So for the quotient property of logs, we have log base b of m divided by n. I'm going to write it as a fraction. M divided by n equals log base b of m minus log base b of n. And again, these both have the same base. And it kind of corresponds, right, to exponents. When we have two exponentials being multiplied together, right, we add the exponents, and when we're dividing, we subtract. So you kind of see the similar pattern here. The last one we're going to do is the power property of logs. So if you have log base b of m, log base b of m to the power of n, it is equivalent to n times log base b of m. Okay, so you can take the exponent and put it down in front and multiply it by your log. So these are the three properties, and now we're going to do a few examples that use these properties. So for the first set of examples, we're going to do 2. I want us to expand the logarithms. Okay, we don't want exponents, we don't want radicals, we want to expand it as much as we can, and we're going to use these properties as well as other properties that we know from previous chapters. So let's expand log base 5 of a to the second times b to the 7th. So because these are being multiplied together, the first thing we're going to do is expand them, and that's going to use the product property. So because we have a product in here, I can rewrite this as log base 5 of a squared plus log base 5 of b to the 7th. And again, the reasoning for that is the product property of logs. Okay, so now we still have exponents, and we have a property that says that we can rewrite this, right? The power property of logs. So I'm going to rewrite this to be 2 times log base 5 of a plus 7 log base 5 of b. And like I said, that is the power property of logs. And that's it. We can't expand this anymore. We are done. So let's do another example that involves expanding. Let's do log of the square root of a divided by b to the 5th. So for this one, we have a radical, we have an exponent, but we also have a quotient. So the first thing we're going to want to do is break apart this quotient. So that's going to use the quotient property to rewrite this as log, and our base is 10, I don't need to write it, so I'm just going to say log of the square root of a minus log of the denominator, which is b to the 5th. So that is the quotient property of logs. Alright, now we know how to rewrite this, right? We learned how to rewrite radicals in a previous chapter, so I'm going to rewrite this as log of a to the 1/2, because we don't want radicals. So that is just rewriting our radical. And now I can use the property twice. We have a power here and a power here. So I'm going to use the power property of logs. And this is going to become 1/2 times log of a minus 5 log of b. And now we are done with this problem. And that was again the power property. Okay, so those are 2 examples of expanding. Let's do one where we are rewriting as a single log. So example 2. rewrite as a single log. All right, so the example I would like us to do is 4 times log base 4 of m plus 3 log base 4 of n minus log base 4 of p. All right, so there's a lot of stuff going on, right? We've got things being multiplied, we have addition, we have subtraction, so we're going to want to use multiple properties. The question is, what do we do first? So it kind of follows the PEMDAS, right? Order of operations. So we're going to start with those powers. And I'm going to rewrite all of these so that the number in front, and there's nothing here, but the number in front will be moved. So my first thing is going to be log base 4 of m to the 4th plus log base 4 of n cubed minus log base 4 of p. So that's just power property. Okay. Now we have addition and subtraction. So remember, with addition and subtraction and order of operations, if we have both, we go from left to right. We want to combine these two first. So log base 4 of m to the 4th times n cubed. And then minus log base 4 of p. So that is the product property. And then finally, now we can use the quotient property. I'm going to do log base 4. This whole thing will be in the numerator, so it'll be m to the 4th n cubed, and the denominator will be p. And now it's written as a single log. And that was just the quotient property. Used to go backwards. So there you have it, 3 different properties of logs, using them to manipulate either by expanding or condensing into a single logarithm. You do need to know these, and practice is going to make perfect, so you're going to want to practice, practice, practice.